Hello everyone and welcome to my channel. My name is Atenas and today I'm gonna show you how to fit a first order model with delay to a step response system. I know this can sound a little bit impossible, but I found an easiest way to do it and I'm gonna show it today step by step. So let's get started. First of all, it is important to understand how this system is going to work. We're going to have as an input this step response following by the system, and it's important that you understand the behavior of each system and the response that you can get. It can be a first order response or a second order response as shown in these pictures. This is the most common way that people does this kind of experiments, so this is why we're going to do it like this. As I mentioned at the beginning of this video, we're going to do it with a delay. We can translate a delay as a retard on a signal, so I'm gonna show with an example what I'm talking about. It is important to mention that we are going to measure this delay in seconds. Most of you should already know how does a transfer function looks. It's just the output dividing the input. So as you can see in the picture, this is how I am gonna write the transfer function. It is important to mention that this transfer function is just for the first order model with delay. You cannot use this transfer function for a second order or any other kind of PID, just for the first order model with delay. And I'm gonna show you later what does every symbol means. For this transfer function, I'm gonna explain what does every symbol means, where K is gonna be the gain of our PID. TD is gonna be our delay time. And T is gonna be our time constant, and we're gonna measure it in seconds. I know this can sound a little bit tricky or confusion, but I'm gonna show you a quick example where it's gonna be easier to visualize what does the transfer function means for our experiment. First of all, as I already mentioned, we have the step response followed by the transfer function. In this case, my transfer function is going to be 20 dividing 5s plus 1. And our delay time is going to be 2 seconds. So if we put these values in the graphic, it will show as the following. As I said, our delay time is going to be 2 seconds. Also, our time constant it's gonna be 5 seconds, and lastly our gain or K is gonna be 20. So this is just a short example, so that way it's gonna be easier for you to see how you can get the different values from your transfer function and apply it to your graphic. By this time you may be asking, but how am I gonna do this? So let me show it the easiest way I found. I found this website called Webplotizer where you can load your image. You need to have your graphic already in a folder downloaded. So here's the graphic that I chose. Then we're gonna use the 2D XGA plot. And as you can see, we're gonna be able to draw 4 points wherever we want. So it's gonna be x1, x2, j1, and j2. We need to get these points some values, so I chose from 0 to 25 and to 25 to 40. So as you can see, it's really easy to interact with this website. And after that, you're going to be able to make some points in your graphic line. I'm going to make the distance closer, and as you see, we have already the dots drawn. We can add some more manually if you think we need more. After that, we're gonna go to the view data button. We're gonna choose the graphing plotty, and we're gonna be able to look at the different graph. As you see, it's kind of a disaster, so we're gonna make it better by just sorting the X column in the way ascending. And as you can see, we have already our graph ready. I would like to assume that you already know these two standards where it's the 6.32 and 2.83%. So we're gonna have the product of both these two values multiplying by 55, that it's our gain, and this is our results. For the first one, it's gonna be 15.65, and for the second one, it's gonna be 34.676. Do you remember the plot we had already gotten by the website that I showed you at the beginning? Well, we're gonna look these two values that I draw on green in the plot, and we're gonna subtract 5 because that's the value of our offset. So the new value of each one, it's gonna be 11.14 and 2.55. Using some metrics, it was really easy to calculate the new values for our transfer function. So you can do it by hand, or you can do it at some website or maybe some software, mathematics software. So you just have to put the values in these two different metrics, and at the end you're gonna need to find the x1. So actually the values that we're gonna find, it's gonna be the delay and the time constant. So that way we're gonna be able to put it in a transfer function in another software like MATLAB. So after this, I only divide A and B, and our results were the following. So our delay time, it's gonna be 0.45 seconds, and the time constant, it's gonna be 2.70 seconds. Using the formula I gave you at the beginning of the video, I'm just gonna replace these new values in our new transform function, and this is the one we're gonna use in our MATLAB software, so get ready to use this one. I already have ready my MATLAB plot, and as you can see, I have my step response. It's gonna be until 55 because that's our gain. I just put the transform function as already mentioned, and we're gonna put an offset of 10. So then we're gonna run this program, and then you can see the final result. Pretty cool, huh? So this is all for today. I thanks for watching, and see you later.